Hello, everyone, and welcome to this much-awaited workshop on space life sciences, one of the most exciting topics in the domain of space sciences recently. And today we are going to focus on career pathways, and we will also have a very interesting speed mentoring session in the end. So this particular workshop is brought to you by SGAC's mentoring program and mentoring committee in association with the Space Medicine and Life Sciences Project Group. So I would like to extend my heartfelt thanks to the communications coordinator of SMLS Project Group, Ivy Mayer, for helping us coordinate and organize this workshop as well. So before we start off with our event, I would like to congratulate all our fall 2022 mentees who were a part of our program the entire year, the entire session last year. And soon we will be reaching out to all our mentees for a brief survey to collect the data on how their experience was, what they learned, and a small feedback that would help us improve and provide better service and better programs in the future as well. So let me give you a brief about SGAC's mentoring program. What is it all about? So every year we have two sessions, one which is called the spring session and the other which is called the fall session. So we have two mentoring program sessions every year where almost 100 mentor-mentee pairs are matched in every session. So how this works is we collect the data and we understand what is the requirement from the mentees, in what field of space science they want to grow and excel, and they are seeking guidance. And then we match them to a mentor who is interested in guiding that particular student or mentee. And that's how the pair is made. And then they spend some weeks and months working together and developing projects. And that's how they grow together and help each other. And over the years, it has resulted in so many beautiful collaborations and project outcomes. And we are going to do the same again this year. So the spring 2023 mentoring session is approaching soon. So I would request you all to keep an eye on our website, which I'm going to paste the link in the chat so that you can go back and take a look. The website is still under construction. Many updates are going on, so please be patient. Wait for a couple of days and it would be updated completely. So then you will be able to find all the information about the 2023 spring mentoring session, how you can participate, and also how you can contribute to this session. Everything will be provided on the website. So keep an eye on the website itself. So here's a request. Before we start with today's session, since in our audience, we have people who were a part of our previous mentoring programs, and also there are people who are pretty much new and who did not participate in the previous programs, we would request you to name or rename yourself in this particular format. First of all, your name, followed by an underscore, and then put MENT. That is a short form for mentee or mentor, if you are a mentor, if you were a mentor, followed by another underscore and the session year, that is fall 2022 or spring 2021. That's how you can rename yourself. And if you are not a participant of any of the previous mentoring programs, then I have a small survey for you. Here's a small Google form, which I would request you to fill it up really quickly. It won't take more than 1.5 minutes. It's a really short survey, so you can do it in your free time while you are watching the slides or while you are listening to me. It will be done really quickly. So that would help us know you better and also to reach out to you, help answer your queries, or provide you with any support or help that you might require in the future. So I would request you all to follow the link in the chat and go and fill out the Google form. All right, so I won't take much of your time, and let's quickly focus on the main part of today's workshop, the much awaited presentation by Dr. Rochelle Velho, who is a medical doctor and the Chief Medical Officer for Austrian Space Forum. So talking a little bit about Dr. Rochelle Velho, She is a medical doctor who is specializing in acute medicine and intensive care medicine with operational and research experience in aerospace medicine. She completed the NIHR AFP in public health and the NIHR ACF in ACCS-ICM with an MPH in 2019, which taught her about the complexities of healthcare delivery during the Ebola and COVID-19 pandemics. In parallel with her clinical training, she is the Austrian Space Forum CMO and has participated in expeditions to test spacesuit simulators in extreme environments. Rochelle is also the founder and the previous co-chair of the SGAC Space Medicine Life Sciences Project Group and represents SGAC on the UN Space for Global Health Working Group. Her ultimate aspiration is to source more space-based solutions to solve terrestrial health challenges. Rochelle has previously and is currently mentoring students at high school, undergraduate, and postgraduate levels. The latter is really important to her as her mentors helped her source opportunities and were invaluable at every step of her space journey. And she wants to do the same for you guys as well. So it's an honor to have Dr. Velho with us today. And now I would stop sharing and transfer the stage to her, and I would allow her to share her presentation with us. Dr. Velho, the stage is all yours.
Lovely. Thank you so much for that kind introduction. I'm just going to share my screen and just double check with Subhajit that you can see it.
Yeah, it's all good.
Oh, brilliant. So thank you, first of all, for inviting me to give this workshop and webinar. I'd like to start with this because for me, this is the inspiration of where it's at, the astronauts. So as a space life scientist and as a space medical doctor and researcher, the astronauts are the center, and with the announcement of Artemis, I think that's where the vision is. So always have something that you feel motivated by, and I think that this is what motivates me. So that was a lovely introduction, and this is just a summary, and there are lots of acronyms in my CV, but essentially I'm a clinician, so my day job is in the NHS in the UK in Birmingham, and what I do is work in intensive care medicine mainly, which is so very sick patients with COVID-19 during the pandemic. And at the moment, I'm also doing acute medicine, which is working in resus. So if you have a stroke or heart attack, you come and see me. So essentially, that's my day job. I moonlight, or my Batman role, on evenings and weekends, and 2 days a week is in aerospace research. So I do leadership roles with the UK Space Life Sciences Association as their treasurer. And I also set space policy with UK space government, and we've just released the Why Space paper during the pandemic. I'm also I'm the outgoing chief medical officer for the Austrian Space Forum. I'm currently on maternity leave, so I can't be doing expeditions just at the moment. But my last expedition was in Oman, in the Omani desert, and I've been to Kanatal for the glaciers and remotely led the Israel expedition as well. And our next one is in Azerbaijan. So we go all over the world to remote pre-hospital environments to test spacesuits and spacesuit simulators, I should say, for Mars missions. And we also have lots of different lunar vehicles and other peer-reviewed projects on that. So I think I'd like to basically tell you a little bit about what I'm going to talk about today. And I hope it's useful to you guys. So I'll give you an overview of space medicine and what space medicine is, in case people around the table online on the virtual table don't know about space medicine. I'll tell you a little bit about my career path, but I want to emphasize that everyone's career path, not just in aerospace medicine, is completely different. It's what opportunities present themselves in front of you, what your passions are. So it's a combination of what pays the bills and what your passions are that drives you to tailor your career path. I'll also give you an insight into alternative career paths within space medicine, but also space life sciences. And we can talk, I know there's life scientists on the call, so I'll talk to you a little bit about alternative paths, and that will probably shape our conversation during the mentoring session. And then I think this Second bit, the first bit's about me, and it's interesting, but the bit that I am interested in giving back to you is how can we shape your career, and what SGAC-MLS may give back to you, how you can interact with that project group as well. And I'm hoping that I can give you a few tips that my mentors gave me. So space medicine is a part of occupational health, so it's a preventative medicine. In order to be a space medical doctor, you need to be a terrestrial medic. So what I mean by that is you need to be an ophthalmologist or even a pediatrician, an obs and gynae surgeon, a neurosurgeon, or an intensive care doctor like myself, or there's 150 different subspecialties in medicine, not just general practice. There's a lot of hospital medicines, and it's not just being a surgeon or being a doctor. So all of those different specialties require anything from 2 to 18 years to train in. Unfortunately, I've chosen one of them that will probably take me 20 years to train. In terms of aerospace medicine itself, prevention is better than cure when it comes to an astronaut on the space station. These are healthy people that we have super selected from the population in order to make sure they don't have any health conditions that will manifest themselves when they are in space in that remote environment. And it's really important that we understand human physiology and human performance in extreme environments on Earth in order to do that. We need to know about mechanisms to help with that. So that's space medicine in a nutshell. And there's 3 tenets. So I always say there's 3 bits to space medicine. There's the extreme environment. So it's the environment, your deviation from normal physiology. What I mean is your heart doesn't behave the same way when you're at high altitude, nor do your lungs. And it's all the way from your cellular and genetic processes, all the way to macroscopic organ systems and your mental and psychological health. So it's not just the one thing. And health is defined by the WHO as something that's biopsychosocial. So it's your biological health, which everyone thinks about, but it's also your psychological and your social interpersonal relationships. That is health altogether. And if you deviate from normal physiology, so your heart rate goes up, or your respiratory rate, or the way that you breathe goes up in high altitude or in certain extreme environments, you need to know which of these becomes abnormal to cause disease. So there's a difference between abnormal physiology that causes disease and stuff that doesn't cause disease. So that's just a really brief overview of space medicine. There are many books written about it, some of which are behind me. But essentially, I'm now going to talk a little bit about risks associated with human spaceflight. So this is why I do what I do. This is what interests me. And it's across all organ systems. And as space physiologists, as space doctors, space nurses, so we don't work alone. We have to work with engineers to design spacesuits to meet those physiological needs. We need to make sure the spacesuit environment and the habitat that somebody lives in is suitable to actually meet those countermeasures. So, for example, your blood vessels stiffen and age faster when you're in space, and it's worse if you're going on long duration missions to Mars. Some people think you may develop insulin resistance and cause type 2 diabetes on the way to Mars, which would not be good. So you need to think about, how do you store insulin? Do you work with space pharmacists in order to think about the shelf life of the insulin? So there's lots of different spin-off questions that come from thinking about, this is physiology, this is what goes wrong, and this is what we can do to try and prevent it or to almost anticipate those issues. So that's how we work within the sector. With the Austrian Space Forum, we very much develop suits to mimic what it would be like in those environments. So we're as part of the medical team for the Austrian Space Forum, I oversee 18 different doctors and medical students. And essentially, we're working on how the biomechanics of the suit restrict movement. What's the suit psychology? What's the psychology of that individual in isolation? We're part of consortium of organizations, including NASA High Seas, the Antarctica Concordia and ESA Concordia sector as well. So we don't do things in solo, basically. Everything that we do is in unison with other organizations working on space analogues. Especially because the space life sciences community is so small, it's so important to collaborate. And this is the paper to read if you're interested in this area. It's by one of my very good friends and mentors, Pete Hodgkinson, and Kevin Fong, Ryan Anderton, and Bonnie Postle. And essentially, it utilizes the Shell model, which is to look at human performance, human factors, etc. And you're thinking about mission. What is your mission? What is the environment to undertake that mission and that flight plan that's been set? And what's the craft and the vehicle that you're using? So go away and read about that if you're more interested. This basically is a very good diagram as well to talk about risk. And I think that it's important to notice that you can't do it alone. So you need data miners, you need software engineers, we need a legal team, a medical ethics team. So it's not something that, so space medicine and life sciences is very multidisciplinary. So whatever you're doing, whatever you're doing at the moment at undergraduate or early career professional level, it can all feed into space medicine, space life sciences, and aerospace in general. So I'm just going to, so this is just something to note. So every grant or funding stream that you have in aerospace, medicine, and life sciences needs to spin down to your patient population or your public population. And this risk tool is basically very similar to the NASA human risk tool. So how NASA actually risk stratifies the common problems in space medicine and what's the next thing to look at in terms of what's the next priority to look at in terms of research. And we did that for COVID-19 patients as well. So it just shows you a very real life example of how we can translate what we do in space for global health benefit. And that's something that I'm very passionate about, but it's also something that you need to make a case for when you're doing life sciences, because you have a patient at the end of it and at the center of it when you're doing your job, be it as a space pharmacist, as a physiotherapist, or as a medical doctor like myself. I think this is a very important map, and I don't know whether you guys know about the roadmap to space, but essentially it shows that there are different environments to think about in terms of physiological changes. You've got the microgravity environment of Earth, but you've also got the hypo-G environment of Moon and a different environment completely on Mars. So I think that that's important to know that environmental variation have different impacts on your human body, on your organ systems and your cellular processes. And that requires different sets of research in lab, in bed rest studies, different bed rest models and analogues on Earth in order to meet those research questions. And these are the space medicine priorities that are set out by this consensus roadmap to Moon and Mars. So as you can see for the GSER, you can see that there's radiation isolation, distance, gravity, and environment. And these different things can be tested out in different environments. So everyone has a role, from people in labs to people who are working on things like NASA NEMO, underwater, undersea projects, to cellular projects. So I think that it's really important to know that there is a role for everyone around the table. And this moves me nicely onto my role in skills. And the center of my role, as I said, is as a physician in acute medicine. As you can see, this is a photo of what my day job looks like in full PPE. It's very warm, and wearing face mask, visor, looking after every single organ system that patient has, because these patients are very sick. So we have a machine for renal dialysis, which was coincidentally a spin-off from aerospace. We have the LVAD, which is basically something that you use for heart failure patients who are waiting for transplant, again, actually developed by a group of engineers and doctors at NASA. So there's lots of spin-offs you can see that help over the years in aerospace medicine and aerospace engineering that have helped this patient here in front of me. In terms of my peripheral roles, so everyone has peripheral roles, and in medicine we call them, we classify them as camp. So in your camp, you've got your clinical roles or your mainstream role, and you can apply this to engineering as well. But on the periphery, you always got an element of research to whatever you do, because you are scientists sat around this table. And then you've got education and mentorship as part of your remit. And whatever stage you're at, you can always mentor the next people coming in, and whether they're in high school or in undergrad or postgrad. And I know there's a variation from the chat messages on this call today. Also, I do a lot of management and team working. So I've had lots of committee roles and co-leadership roles with SGAC, as well as with other organisations in the UK and abroad, and policy setting. So we writing white space papers for your, or position papers for your sector is really important. You learn a lot because it's setting your future direction for what the research, your research priorities, but you can then set what the future is in your specialty, in your country, or on a global level. With SGAC workshops, you get to do that on a global scale, but it's very important to give back to your community as well and influence your community, whether that's in education or within the space life sciences sector. So just to give you a little bit an oversight, so I call this this is the model that I sort of built. This is like your sphere of influence, as it were. So you've got at the center what you do as your day job. So you're a PhD student, or you are a junior doctor working in hospital, or an ENT surgeon. And then on the periphery are those peripheral roles that everyone seems to have in common. So research, medicine, teaching, etc. And everyone will do those to differential levels, depending on what your passions are. And some of those peripheral roles might not apply to you because you're spending your time on other roles. But when you see a job specification, for most jobs, they will ask about management, education and teaching, whether you're teaching other people, team working and networking. So these are the things that are common foundation of the majority of jobs out there. Having applied to jobs in leadership, in management consultancy and in medicine, this is the commonality. What I've put in purple are your skills. So you've got your roles in the middle, which are in blue, and you can write this map for yourself, your current map and future map, and I'll go through that. But essentially, the space analog stuff has required me to have in hospital skills and pre-hospital skills. So this applies more to the medical students or doctors around the room. So you have to think about the qualifications you need to work in a pre-hospital environment. To work on ESA Concordia as a doctor, so in Antarctica, you need to have ALS, ATLS, EPLS, not so much ETC. So these are all emergency medical qualifications. You also need experience with analogs before you go to Antarctica. So have you been on expeditions? These are questions that you get asked in interview. In terms of research, so my interest is in aerospace and public health and global health research. So how can we use aerospace data or Earth observation data in order to predict the next wave of the pandemic? And we worked on a NOVID project, which was essentially with SGAC, people in EO and public health, in order to work out how can we use current data to feed into machine learning algorithms and feed forward into making a weather forecast for COVID. And we presented that at UN Copious as well as IAC last year. So this is just a sort of a flavor of what you can do. In terms of education and mentorship, courses, again, training, mentorship training is really important. And with UNUSA, the Space for Women mentorship team, they do lots of webinars with that, etc. But there's mentorship training that I've had at my local university. It doesn't matter at what level you're doing it in. It's really important to get this knowledge in different ways. And it's important to seek out these skills almost in advance. In terms of managing and team working, again, lots of courses, but I learned the most from my mentors, asking them questions, and my peers. So my co-lead, Anthony, I learned a lot from. And then in terms of policy setting, teamwork with UK Space Labs and experience with Space for Global Health working group within UN-USA. So at the beginning, when I was at school, I didn't really know what I wanted to do. So I actually did lots and lots of different work experience in hospital as a teacher. I went to court, to civil court in the UK, shadowed a lawyer, went to criminal courts. I didn't know what I wanted to do. And I think it wasn't until I did my work experience in hospital that I realized what I wanted to do. And this is just a brief summary of how I got there. And no, I can't time travel like Doctor Who. I wish I could. But essentially, this is just a generic sort of pathway. And I think that whatever you're doing, work experience is a deciding factor. Even if you're doing a PhD, it's really important to take time out and maybe 1 or 2 weeks in order to get experience in your sector. And it can be, work experience doesn't have to be streamlined. So I remember getting asked at my Cambridge interview for medical school, okay, what work experience have you had? What transferable skills have you had? And I was like a rabbit in headlights. I did not know that going to space school and Kent Space School was useful. That was actually something I learned from. I learned about scientific method. So I think that's how you actually utilize the experiences you've already had or you're about to have in order to develop that skill set or lexicon of skill sets. So you need a toolkit of skills, and you can get them from lots of different sources, including work experience. So a little bit about, so I had a very straightforward, I went to school, got some GCSEs and A-levels, had loads of applications for medical school and genetics as well. And I got into, the one that I really loved was Birmingham. And that's where I stayed. Birmingham and Bristol are the 2 universities that I've trained at, and Warwick as well. So there are lots of entrance exams and lots of interviews. And I think that this doesn't apply too much to the people around the room, but I can come back to it if it's interesting. But after the University of Birmingham, and after thinking about career in orthopedics, because I had a bit of a brainwave that I wanted to be an orthopedic surgeon, then realized that actually I didn't want to be hammering people's humeruses and things every day. I then got offered the opportunity to go to the European Space Agency, and I think that that's really important. So the European Space Agency has lots of opportunities for life sciences and doctors, healthcare professionals in general, but other professionals too, to do courses. And this was I was actually at the first ever course for space medicine as an undergraduate. And I've also done the space physician course. So if you've graduated from medical school, there's a space physician course. And ELGRA and CELGRA have just announced that there are applications open for their course, which is on life sciences, run by ESA and CELGRA. So I would definitely encourage you to apply to them, because what's the worst that could happen? You might not get it this year, and you can apply again next time after learning from it. And that was a real pivotal point in my career, because I did that after second year, third year of medical school. And essentially that involved meeting lots of people from around Europe, a lot of which I'm still friends with and I still network with quite closely, because those medical students have gone on to become medical doctors and researchers or operation managers within ESA. And we came up as a group with novel techniques to do CPR in space, and resuscitation became a big part of my research career. And I would like to say that, I know it's a bit blurry, but I love this quote, because essentially going everywhere and being quite a global specialty, aerospace is incredible because you get to meet so many different people. I was talking to Yashika before this call, and essentially we were saying that at IAC and going to SGAC workshops is invaluable for your career progression as well, because of the network that you build and that peer mentoring that you get, because you can learn from other people, as well as people reverse mentoring people coming below you who are the next generation and people above you. So I think that you can find different points of learning, so not just from work experience but also from others. My medical elective, so if anyone's a medical student, your elective is really important in order to gain that work experience. I did my terrestrial elective, as it were, at KM Hospital in Mumbai, and essentially it was in intensive care and anesthesiology and A&E. But then I went to the ISS workshop in Germany and ended up with a project with King's in Brazil at the Centro de Microgravidade with Professor Russell Mano, who is now in charge of Innova Space and continues to be a very inspiring mentor. And I then organised a conference during my elective as well in Aberdeen on aerospace medicine and life sciences, and it was one of the first in this country. So, and the person who gave the keynote still inspires me today. He talked about, so he was the lead physician on the Red Bull Stratos project, so the jump from the edge of space. So I got to learn all about Felix and Red Bull Stratos, so that was really, really interesting and inspiring. This is my first paper. I'll put this up here because it's really important. I think your first publication or your first presentation always stays with you, and the 3 Ps are very important in a career. So presentation, publication, and prizes. And unfortunately, these are the things that are very important in medicine as well as life sciences in order to get your terrestrial job and career progression, as well as in space medicine. And if you want to be an operational flight surgeon, or if you want to do life sciences research. So it's really important to, even if you are a very small cog in that wheel, it's very, very important to get involved with projects that lead to outputs that are meaningful for your career. I would also say that if you're in the UK and if you're a medical student, this is how it works. So essentially, you go to med school, you do 2 years of foundation training or internship in the US, which is 1 year. And then you can drop out of that program to do a PhD or an MD, go back in, and then get funded for 3 to 7 years to do your up to consultancy. For women or people who go less than full time to do other things, that actually doubles. So it can take you up to 14, 15 years to actually become consultant. And during that whole time, from being a foundation year doctor, you're a registered doctor, all the way through to consultancy, you become more and more senior, you gain more and more skills, but you're still considered in the UK to be a junior doctor. And you might have seen us in the news if you're in the UK. So essentially, this is the training pathway. I can talk more about it if people are interested. There's an academic training pathway in the UK, which is very unique. You don't really see that in other parts of the world, but it means that you get dedicated time to do research. And that's what I did. So I did a dedicated research project sponsored and funded by the NIHR in the UK, which is a part of UKRI and NHS England. So essentially, I'll put this on, and I know that this might give some people nightmares because this is probably in most exams for life sciences students. But essentially, this is a very good tool to remember what you need in order to build your career. So you need your clinical side, or your say you're a pharmacist, or your pharmacy, etc., your knowledge and your acumen, so your terrestrial career. And I will say over and over again, it's your AMP, so your academia. So what have you done in terms of research output, publications and prizes? And having been on this side of the table, as well as at the other side of the interview table, so I've been both a part of the interview panel for doctors as well as the other side, I would say that we look at academic outputs because that's the only way to really work out what your outputs are and what your progression is. what your research projects are. In terms of management, have you had any committee roles? Have you been part of any wider committees in SGAC or beyond? What are your teaching experience? Have you mentored anyone locally or globally? And on a personal level, do you do anything other than work? So I do choir on a Wednesday. I've been part of lots of different choirs over the years, it's just unfortunately, it does feel like you have to be a bit of a superhuman, but actually if you go away and think about it, you probably already do all these things. It's just how you classify them at interview that's really important. So I worked for Public Health England during the Ebola pandemic, and that's where I envisage my career going forward. And that's really important. I think the tip from this slide is be flexible to a certain degree and say yes to things, but say yes to limited things so that you can actually do those things well. So pick three. So my rule is 3 things. So make sure you have 3 big projects and do those 3 big projects and do them well. If you have good opportunities that come along, you may need to swap them out with something that you're already doing, pause something and do that, or say, no, I need to move on, or do you need to postpone that? So I think that's really important. And I think working for PHE was one of those things that was absolutely life-changing and very interesting. Another opportunity that came along for me was to work as a junior doctor for Austrian Space Forum for the Canutal Glacier, and then to actually lead the whole team for Oman in Amity 18, and then thereafter for the Israel mission, and now for Azerbaijan, I'm a consultant for them. So essentially, this is one of the projects that I came up with, but this is something that I definitely said yes to because it fitted in with my goals. And this is just a summary of my camp structure. So my clinically, I work in hospital, and that's the majority of my time. That's 3 days a week when I'm not on maternity leave. My academic stuff is all with the Austrian Space Forum, but also with universities like University of Warwick, King's, Imperial at the moment. And then working outside to have fun, to de-stress. I don't go to the gym as much as I should do, even though I pay an exorbitant fee to the gym membership. But I do a lot of stage work with Gilbert and Sullivan Society and singing. So I think it's really important. And I'd like to say that mentorship is so, so important to me too. Now I'm going to go into alternative careers. These are all my friends on this page. And essentially aerospace medicine and life sciences is a very tiny group of people. Everybody knows everyone or has worked with someone at some stage in their career. So essentially, I've got Adrianoson here, who I did the Canutal mission with, and he's now an ESA flight surgeon who worked at Concordia as well. Bonnie Posselt, for anyone in the UK, she is our second consultant in aerospace and aviation medicine. It's a very new specialty in the UK and a very progressed specialty in the US. You've got Beth Healy here, who was at ESA Concordia. You've got people who are space physiologists. So Phil Carville is now one of the leads for STFC, which is basically a grant commissioning body in the UK. So they give you money to do research and they facilitate networks for space. So you may have heard of ESA Harwell in Oxford. Phil runs that. So I learned about Phil and I met him. I was lucky enough to meet him during my work on the committee with UK Space Labs, but also he developed one of the flight suits as part of his PhD project. So he's a physiologist by trade. You've got Kevin Fong, who jumps out planes and is on TV. So he's very much about science communication. He's written lots of books. Andrew Winard, who is a space physiotherapist. So as you can see around the table, you've got people in the military, you've got people who are pharmacists, physiologists, physiotherapists, engineers, and astronauts as well. So you've got a bunch of people who contribute to this field. And I'd just like to say that I'm just going to talk a little bit about the role of flight surgeons and how you get there in the UK. So there's a specific training pathway. Look on the GMC website. There's a curriculum as to what you can do in order to get there. And there's so many different roles within space medicine and life sciences. I can't go through all of them, so I'll talk about what I know about. So in terms of remote medicine, you can be an expedition medical doctor going up Mount Everest or to Antarctica or the Arctic Circle or the middle of the desert or caves. You can be an aerospace medical examiner. Now, this means that you can be a general practitioner or somebody who works, does a terrestrial career, does a few exams, and you then do pilot physical. So it's mainly aviation rather than space. And aerospace medical research, which is what I do. So I do a little bit of operations and remote medicine, but my main goal is to really improve as a researcher. And I think you need to pick where your path lies at this stage, because then you can develop your career and your skill set in order to meet that pathway. And the best way to actually meet that pathway is to talk to people who've done that pathway, which is why you guys are here today. So any specialty in medicine or life sciences can translate to expeditions or translate to space medicine. I know that Surajit said that he's doing genomics. So I know people in space genomics who work with NASA Gene Lab, which is an up and coming area of aerospace medicine and life sciences. And cellular physiology. And there's lots of different ways you can contribute to that. But reaching out to people who are first authors on a paper, you've read a paper, you're interested in it, reach out to them. That's a good way to actually say, hi, I'm interested, I want to get involved. And if they don't have the capacity to have you on their team, we're very nice in life sciences, space life sciences, we will signpost you to somebody who is relevant if we don't have capacity, or we will welcome you with open arms to our project. So I think that that's very important. A knock and hopefully somebody will answer. I think that's something that I did very early on with King's, and I think that that's something that you would benefit from as well. I put this on here because it's not just all about work, and it can become all about work very quickly. So it's important to think about what's important to you. So when you map, so go away, look at the Ikigai principle. It's something that I read about when Tim Peake was writing in Limitless, his book. And also something I spoke to the Japanese astronaut Chiaki Mukai about when I was at UN Kupios. So essentially, you're thinking about not just your mission in life and your vision and what your passions are, but what delights you, what makes you complete. Is it what the world needs? Is it what you can be paid for? Because at the end of the day, you need to get food on the table or have a roof over your head for your family. But is it what you're good at and what you love? So I think that these are the tenets that I try and live my life by, and it's very hard to do sometimes and very hard to juggle. So I will say that you will not always succeed, and that's okay. It's okay to fail, but it's important to know how to fail. It's important to reflect on that failure, maybe 3-4 days afterwards, come back to that and work out what you would do differently next time. Don't let it hold you back. Work out how it can move you forward. I've had bad interviews, I've had bad exams. I didn't get to this position without failing 10,000 times. For every thing that you see on my CV, I've probably applied to 10 other projects that I did not get, or 10 other projects that did not make it. So I think it's really important to know that you see a lot of these careers talks, it can be quite overwhelming, but take a step back and think, actually, we are human, and it's important to know that you should have balance in your life as well. So this is a photo of Bonnie and myself on our mission just before Oman. It's really important to have a team around you, not just to lead that team from within, but to also work out who you can talk to when things go wrong, when challenges need to be fixed, because that's the only way that you can be truly solution driven, is to collaboratively work within a team. And we worked with astronauts, so you can see our analog astronauts here, Kartik and Inigo, as well as the medical team, in order to work out how can we make something as simple as the suit less heavier. something as simple as reduce the glare of the screen. We had to then work with the head-up display engineers in order to change that. So I think that it's always working with each other to meet those solutions and those challenges. This is what you can do in the UK if you're interested in space medicine. There's not that many positions. There's one or two that come up every year, and they're mainly military. So that if you're with the Royal Air Force, so this is what an AME can do. Or you can just do AME as part of your portfolio as a GP or an acute medic. So there are lots of different options, and they all map onto different pathways. And unfortunately, there's lots of different exams along the way as well. And I don't know whether non-medics in the room know this, but we tend to do 3 or 4 different postgraduate exams, sometimes 7 or 8, and each of them costs about £1,500 to £2,000, which is usually half your salary as a junior doctor. So in the UK, which is why we're currently on strike, as you've probably seen in the newspapers. This is what I do. So this is aerospace medical research in the UK, and you do you can do academic foundation program training. So you get 4 months out to do research. You get 9 months out if you're doing it between CT1 and ST3. And then you can do clinical scientist fellowships. There's so many different options and so many different funding pots. And that's where I would say for medics and non-medics around the table, there is funding if you look for it. Apply for 10 grants in order to get that 1 grant of funding. Apply for scholarships to attend conferences. So ASMA has lots of scholarships. SGAC has lots of scholarships available. Think outside the box as to how you can attend a conference. Could you volunteer at that conference? Like IAC, you can volunteer and go for free. So you can volunteer your time to stand outside a door, for example, wear a t-shirt, hand out different things. Obviously, you have to apply for these roles, but there are ways to make your opportunities happen. And you can get money and funding if you look for it, if you are interested in doing research on Earth. So in terms of aerospace medical research, whether you're in life sciences or in medicine, there is a role for you pre-flight, in-flight, and post-flight. And I say this to all my mentees: selection, thinking about genomics. What are the genetic traits required in order for selection? That this is quite a medical ethical question as well, because are you ethically allowed to select based on your genes? Well, if somebody has a predisposition to Huntington's disease, something that's quite a debilitative neurological condition, do you want that person to be your pilot going to Mars? Probably not, because there are only 4 or 5 people in that capsule, and you want to make sure that you don't have somebody with visual chorioform disease that may manifest. And that is a hard decision to make as a flight surgeon, as a life scientist, but it's something that's important. In flight, you've got prevention and monitoring. So you've got things like VIP or SANS, so space-associated neurological syndrome, that are very much becoming apparent as a condition. So what are the countermeasures? What can you do in order to prevent that from progressing and becoming a problem? Because that can blur your vision. If you can't see what you're doing, it's not great as an astronaut. So, and I don't know whether you guys know this, but they actually have a drawer on the ISS with lots of different glasses, as if you're at the opticians. So they have to be each other's opticians, the astronauts up there, they have to learn that skill in order to then wear a different set of glasses, because often their vision changes. We don't know whether this is purely due to SANS. This can also be due to lots of other factors as well. Post-flight, rescue and rehab, human factors, monitoring, managing, training. There's so much out there in terms of opportunity. Legal consultancy, management, indemnity. So this is just a bit of something to just break up the talk a bit. But essentially, I just want you to write down on a piece of paper, just an individual exercise, which chocolate bar you think represents the bones of an astronaut when they go up to the ISS. And then the second question is, what's what do their bones look like when they're on Earth? So I think that just write that down, whether it's picture A, which is your aero chocolate bar, or whether it's the crunchy bar. So what does an astronaut bones look like? And I'll come back to that at the end. So I'd like to just stop there and ask whether there's any questions, and just like to open the floor, and then I'll just talk about any career tips as well after this.
All right, sure. I did notice some questions from Robandeep, so I would request you to unmute yourself and ask the question to Rochelle.
I don't think
Robandeep, can you hear me?
Yeah, I can hear you. Hi, Subhajit. Thank you for the wonderful session. Hi, Rochelle. This is one of the best session I have ever attended. Thank you for being here. So my question is I am from bioinformatics background, having done my master's in bioinformatics, and currently I'm doing my diploma in data science thing. So I have got interested in space now because I'm doing my internship somewhere. It's related to same space. So wanted to know that how can we, transform from bioinformatics to space, like having done my master's in bioinformatics, how could I contribute in space? Do I need to do PhD for that, or is there any course for that? Then how can I step into this field?
Yeah, so that's a very good question. And I would say that actually, if you're doing any projects at the moment, are you at master's level, or are you undergraduate? Are you like BSc level, or are you in a?
I did my master's back home from India, and now I am in Canada for my further studies. So,
yeah. Okay, so essentially, not everyone has a PhD in the aerospace sector in life sciences. I would actually encourage you to look at the NASA Gene Lab website. They have and NASA Gene Lab webinars, and attend the NASA HRP, which is the Human Research Program conference, which happens every year. But NASA Gene Lab have an open access system. So if you have bioinformatics as your background and you come up with a question, make sure it's related to what you've done in your master's or something, so that you understand that area. You've already done the literature review, and look at the open access NASA Gene Lab data. You can request that data for free if it's not easily accessible to you, depending on where you are. If you're in Canada, you can easily access that. You can easily tap into that, and anyone can ask for that because they've got a big data repository of animal data and a limited amount of human data. And you can then analyze it if you've got a question in that area. For example, if it's on musculoskeletal physiology and you want to work out which genes are upregulated in certain, mouse models, that data's already, there's a big set of data that's already out there. They just haven't asked that question yet. I would do a scoping review on PubMed or OeWF just to see whether that question's already been asked. You can also look at the NASA NTRS website or database to see whether that question's already been asked. But essentially, that would be the next best thing for you to do. And there's a whole list of people on the NASA Gene Lab website that you can contact or get in touch with. But essentially, it depends on which area of bioinformatics you want to explore further.
Talking about management consulting, so how about this thing, like what can we do in this particular area of space?
So management consultancy, so more broadly, so people like management consultancy firms like McKinsey, for example, they're looking for a broad range of transferable skills. So you've gained research skills, probably coordination skills, project management skills within your master's and what you're doing at the moment in your internship. So you can utilize that when you apply for management consultancy, but they're also looking for whether you've got any foundational skills in management. So have you done any courses or have you done any workshops in specifically for management, whether that's online learning, virtual learning, or in person? If you want to apply for consultancy, they want to see maybe, have you been on any committee positions? Have you been actively involved in them? So I think these are the main achievable things that you can do at your level in order to make you more employable for a management consultancy firm. For other things, management consultancy firms in life sciences actually have a lot of webinars themselves. So depending on which firm you're applying to, you can go onto their website, sign up for their newsletters, get to know them, work out whether they're a good fit for you. And also they run a lot of in-person sessions for free at universities and different offices around the world. So it's important, once you've gained those initial skills as being a leader yourself and doing a course yourself, to then go to one of those meet and greet sessions, as it were, with the firm. Does that answer your question?
Yeah, thank you very much.
Perfect. So I think I'll just ask the other questions later, and I'll just carry on with the talk, if that's okay. Yeah.
Okay, yeah, sure.
Yeah, perfect. So moving forward with your career. So I think that this is the model that I use from Berkeley, but essentially it's about planning your career. And I think a career development plan is really, really important. And it's important. I'm still writing down career development plans on a 6-monthly basis. It's something that you need to regularly revisit and review. And if you've got a family, if you've got dependents like children or a mum and dad who you're looking after, etc., you need to also regularly review it in that context, because you may not be able to geographically move, you may be stuck in a location, etc. So those are all really important to bear in mind when you're developing your plan. So what's your current situation? Where do you want to be in 5-10 years time? And they ask you this at most interviews. Perform a gap analysis of your skills and create a map of what you want to do, how you can get there. So next year you want to be, I don't know, SGAC, part of the SGAC mentoring team. The year after, that will give you certain skills in management, etc. So I think that that's how you perform your gap analysis. And when I look at myself at the moment, what is your current sphere of influence? So what is your role at the moment? What are your additional roles, those roles on the outside? And how does that get you to your space jobs? And when you think about space experience or work experience, think outside the box. Is it with scouts? Is it volunteering? Is it air cadets? There are lots of different ways to gain transferable skills that will then make you a good fit for space life sciences or space medicine or any career in aerospace. So look at your sphere of influence at the moment, and then draw another diagram where you're essentially, what is your future sphere of influence? And this is an individual exercise. It's very personal. It's something that you need to go away and do. And I can send you the slides afterwards via the mentorship team if you're interested. But essentially your sphere of influence is, are these skills achievable? Can I achieve this within this time period? And those are your SMART goals, essentially. So you've done your gap analysis and map it to the person's specifications of your future job. What do you want to do in the future? So I know Rob and Deep said, okay, management consultancy. Look at what just Google jobs, or Indeed, look at a job site, look at what they're looking for in management consultancy and see how you fit at the moment and where your gap is. Like, what are you missing? And there was a study that was done that was looking at women in particular, women applying for aerospace positions and other positions. And we tend to want to get 100%, every single thing on a job specs needs to be ticked off. Whereas people who identify as male tend to only want to tick off 60 to 70% of those job specs. You don't need to meet every single criteria on that job application in order to apply. So I think that's really important as well. So your gap analysis is never going to be complete. It's always going to be evolving, and it can be overwhelming as well, but it's okay. It's okay, because you are following a vocation, you're following something that you're passionate about, something that you will be doing for the rest of your life till you retire. So it's a really excellent skill. It's something that one of my mentors taught me, and I'm hoping that will help you as well. And always make sure, if you are a life scientist or a doctor, that your central role is terrestrial, because your space role is not guaranteed. So make sure that you have a job, maybe working 2 or 3 days a week in a hospital or in a lab or in front of a computer if you're doing omics. Make sure you have that role. And it's really important to be an expert in your terrestrial role before you move into the space sector in space life sciences, because we want to see that you have gained that terrestrial network in order to progress. So I think that's really important. And career planning can feel very, very stressful and very overwhelming. And it's hard when you look at your strengths and your weaknesses. It's hard to define your goals and what qualifications you need to get next. So I think it's important that to realize that with every success, you may get a failure, or you may get multiple failures. And that's okay, because a lot of people aren't open about it. But I will tell you now, every single person at my stage has failed at some point, be it, and somebody like in athletics, look at Serena Williams, she talks about it very openly. It is something that's okay to do. It's how you deal with it. This is just a template that I was given by one of my mentors a long time ago. But essentially, what is your vision? What motivates you? What do you want to get to? So that's your gap analysis and your sphere of influence. But then what do you want to do in terms of your 3 to 6 months, 6 to 12 months, 12 months, and your long-term life goals? So, what are the quick wins? Can you do that Future Learn course next week? Is that possible for you? Because you don't want to fail your exams or anything in order to achieve that course. So are these tangible actions that you are putting down on paper? And make sure that you don't put 20 things in that one box. Put 2 or 3. And I think it's better to do 2 or 3 things well than to do 10 things badly. And that's something that I've learned over time. Saying no is hard, and you feel like you're letting down your mentors, but you're not. You're being honest. You're saying that, actually, can I postpone this to next year because I don't have capacity for it this year? And it's okay to say that. Learn to say that more often. So I think that that's really important. When you look at any person's specification in aerospace engineering, in literacy, in aerospace medicine, these are the skills that people look for. Are you proactive? Are you self-startering? What does this mean? I mean, there's a lot of, word jargon here. Are you self-aware as a leader? What does this mean? I think it basically means that, have you been in a leadership role and have you learnt about how to lead? Have you done any courses? Have you learnt about how to manage and empower team members? Have you learnt about accountability and probity, in a clinical role? Have you done any teach the teacher training? Have you taught others how to do this? Are you adaptive and flexible? And that can only really, and whether you start and finish projects is only evident from whether you've got any outputs really at the interview stage. Have you done projects and have you got references for them? Or have you got tangible projects with publications or presentations, whether that's oral presentations or whether that's virtual presentations or poster presentations? It doesn't matter whether it's local in your own university or your workplace, all the way through to somewhere like IAC. It doesn't matter where it is. You would all have these skills to a certain degree. Your progress bar on each of these skills, if you think about them, is going to be different for each skill. Some people can lead better, some people can teach better. So I don't think it matters as long as you try and encompass the whole domain of skills. So don't just focus on one skill. Think about a broad base when you are writing your career plan. And that's another thing that one of my professors told me. Just to finalize my talk, I'm going to talk about, you already know about SGAC. This is Anthony, who I co-founded it with, and you probably know him as the chair, as the now outgoing chair. SGAC-SMLS was set up because we needed a GPS system for how to actually, because we didn't know about space medical events, opportunities, etc. So it's very new as a field in itself. And this was my community. This was my, these are my people. So these are the committee that helped me take SMLS from basically an A4 page, an idea, to actual action. And this is a bit about the project history, and I can send you the slides if you're interested, but essentially, how can you get involved? Make sure you join the Slack channel, make sure you join the Twitter sphere, ask questions, network. So I think that go to their workshop, go to their webinars, learn. So knowledge acquisition at your stage is very important. Think about the events that they're doing. Can you go to the Health in Space webinars? And I know Ivy is setting up lots, and it's all on LinkedIn or Twitter. And how can you collaborate on research projects? If you've got an idea for a research project and you need a team, the Slack channel is somewhere where you should be able to post maybe a poster as to how many people you want. You can interview team members with permission from the SGAC committee. And that is the sphere, that is what the project group should be for, is to come up with new projects. And as you can see here, we're at the European Space Generation Workshop. We worked with Merck, which is a very eminent pharmaceutical company, in order to work out how pharmaceuticals can be used in the space flight settings. And that led Anthony and me to work with NASA on their space pharmacology development arm. So it was just, what networking is so important. Collaborating in SGAC will lead to other things. So I think that's really important to do. And this is our last systematic review workshop. I think some people on the call were part of this workshop, but essentially we had 54 people, part of 9 different teams with different mentors. So we will do it again when Anthony has a bit more time after he's had a break from being a chair of SGAC. So look at the website, look at Twitter, look at social media platforms, look at Slack, engage and talk to authors, talk to people. What's the worst that could happen on LinkedIn? They don't reply. I've had that lots of times, but actually it's really important just to keep the conversation going, and that will help you then achieve your goals. And these are a certain set of questions that I was asked when I presented at one of the Oxford space talks, but essentially I think I've gone over all of these, but I'm sure that you guys, I'll keep these questions up. If any of these I haven't gone over, or you've got additional questions, we'll go to that now, if that's okay. So before I finish, the chocolate bar in space. So your bones look very aerated and are very liable to break when you actually land on Earth or Mars, when you're on the ISS, due to bone deconditioning. And you guys might know about Wolff's law, about what happens to your bone cells on a cellular level, and then your osteoblasts and your osteoclasts, and then and that's because there's no gravity. Well, micro G, free fall engineers will be like, there is gravity, but it's just in a different way. And then in terms of your crunchy bar, that's how your bones should look as a healthy young person, with the nice bone mineral cortex, and then you've got that a bit of aeration in the middle, but not too much. And that was my intercalated degree project at Bristol, was looking at bone formation and osteogenetics, which was a long time ago, in 2009. So as you can see, space applications, lots of stuff out there for global health benefit. And I will take your questions, and I'll go back to this page because this might give you a little bit of a conversation starter for what to do.
Thank you so much, Rochelle. That was such an amazing presentation, and you touched upon so many important aspects that are definitely going to help all of us in many different ways. So I won't do the talking much, because I see there are many people who want to interact and ask you questions. So I see Yumna raising her hands. So
hello.
Hi,
Yumna, you can, yeah, go.
Hi, I hope everyone is doing good. So I will be quick because I have 3 major questions. So I am an allied health professional. I completed my BS in medical lab technology in 2020. I have been trying to kickstart my career in space health because this is the way to combine my passion and profession. I was a part of SMLS workshop, systematic review workshop as well, but it ended quickly, I would say. So how to join a space research project remotely, but more importantly, how to figure out that this project is meant for us and this will stay longer, or maybe this will not just float away in the space. And
Yeah.
secondly, may I ask one by one questions?
Yeah, why don't we start with, so the first question is, how can you get more involved as an allied healthcare professional in the space sector? Your second question is, how can you get involved in projects that are longer? Is that right?
Yeah, which are actually sustainable. And regarding the courses that you mentioned earlier during your presentation, what course do you recommend? Courses or training do you recommend which is open to all nationalities? For example, the one by ESA, sometimes they're only for specific nationalities. So I have tried applying, but no luck. And the most important question is, I'm actually trying to look for a master's degree, which is very much relevant to space health. Yeah. And what are the universities all over the world who are active in space health, where we can actually find the professors who are working in space health so that we can just apply over there?
Yeah, so I will start with about courses and the master's degree, and then I'll go on to the other bits as well. So in terms of courses, so online on FutureLearn, and also MITx has a very interesting course that's running at the moment that I've just enrolled into. You don't have to pay anything if you don't want a certificate, but I think if you want a certificate, it's like $20 or something very nominal, something very not that bad. So essentially, MITx does this course on, I think it's on aerospace engineering and biomedical health. I can give you the exact details. I can't remember the exact name of the course, but it's run by one of the professors in aerospace engineering, and it touches on space health. So you can do courses online that are accessible, and I think those are just as useful. King's College London runs an online course that anyone can join, and I think it's £500 or £1,000. I don't know whether they've increased the amount of money you have to pay every autumn. It's not run throughout the year, so you have to be careful like when you apply. But essentially, it's on aerospace medicine and life sciences, and it's mainly on aviation health, because I don't know whether I mentioned, but essentially you need to know the aviation and terrestrial physiology, the extreme stuff, what happens to a pilot, in order to work out what happens to the astronaut, because everything that happens to a fighter jet pilot is applicable to astronauts. So I think that's another course that's really good. There are some, I think Monash University used to run a course in Australia. I don't know whether they still do, in aerospace medicine. I don't know whether it's restricted to doctors or whether you can do it as an allied healthcare professional. I think if you ask, I mean, you don't get anywhere unless you ask. King's runs a course for aerospace doctors, so you have to be postgraduate, have a few years experience. I don't know whether they let allied healthcare professionals on, but essentially, and I know they have let an RAF nurse on actually before, but it's mainly military, and I think it costs 26 or 27,000. So it's quite prohibitive in terms of how much it costs in the UK, and that's just for home students. So I don't know how much I dare to think, you know, how much it is for abroad. Doing generic courses, so other master's courses, the ISU, so International Space University, has a master's, and I know that Shauna Pandya, one of my really good friends, she does a lot of space medicine and life sciences. She did that course and found it really useful. ISU does this SSP program. You've got I think that Virginia Watring, who was very eminent in NASA and is now one of the faculty for ISU, is running a short course in Oxford on space omics, and that's open at the moment. I don't know how much that costs exactly. I think it's 2,000 or something like that. So I think that that's another. There are lots of courses out there, but it depends on what your whether it matches what you're interested in. So in terms of space technology, there's lots of different like small webinars and different workshops within bigger conferences like IAC and ASMA, so the Aerospace Medical Association conference in America. You've got ICASM or ICAM in which happened in Paris last autumn, but IAC is probably the way to network. And that leads me on to, so you're talking about, so I've talked a little bit about courses, talked a little bit about MSc. I would also say, in addition to courses, are there any local military or civilian centers where you live that could offer you work experience? So I think that's really important. And when I first started, I was working, I was in a lab doing osteogenetics, knew nothing about space until one of my mentors told me, oh, have you, your work links to aerospace. Why don't you go into aerospace? Why don't you look into it? That was the first time that I did it. I think that it's, if you're a master's student, you can do a generic master's in anything, as long as one chapter of your dissertation or 2 chapters is on space. Make sure you choose your project for your dissertation to match something that overlaps in space. For example, one of my friends, Ilaria, I don't know whether you know, Ilaria Cinelli did a PhD in biotechnical engineering in Ireland after doing the Masters in Space Physiology and Health at King's. She's from Italy, so she's considered to be an international graduate in the UK. And essentially, she is now doing work on human factors, because part of her PhD project, was on human factors, which is completely removed and different from what she did, which was on biotechnology. So I think that you can tailor any PhD or terrestrial project to have 1 or 2 chapters or 1 or 2 publications in space. You will never get a pure space PhD or master's necessarily. It's very difficult to get onto those courses. It's actually trying to be innovative about how you can use what you're already doing in order to do a project or a spin-off publication in space. For example, one of my friends, Marlies, she's very eminent now in space pharmacology. She's a pharmacist. She did pharmacy as a BSc. She then looked at how can drugs be stored in space as part of her PhD, and that's become her whole life now. So I think that it depends on how motivated you are. Or you can be like me, which is do lots of different projects. So I've done CPR in space, I've looked at space and global health stuff, I've looked at space policy. If you look at my ORCID ID and my publication record, it's just so random. It's in renal physiology, medical education, ethics. I follow my passions. You can be a generalist or you can be a specialist. And I think you need to work out what your personality type is. Like, do you want to specialize in one area, like space pharmacology, and that's it? Or do you want to do lots of different areas? I think it's easier to do that if you're in a broad specialty, like say like space omics. You can look at omics in animal models or human models. You can look at genetics in archaeological streams. It's such a broad, you can look at evolution. There's so many different streams that are aligned with generalist and broad-based things. So I think it depends on what you would like to do next, what you're interested in. And I would definitely say do something that you're interested in and what drives you when it comes to your master's.
Just the last question. I'm super interested in genetics, and I want to study majorly genes and space. For that, for now, I am in my country. What skill you would suggest me to gain? I do have a university and a few labs over here. I worked year in a COVID lab, we were researching on which genes are involved in COVID-19 and causing COVID-19. And for sure, it was not related to space. We don't have space over here in my country. What skill you would recommend me to gain, which can help me in future when I am kickstarting my career in space health?
I think it's just general skills. So in omics, so in terms of, so there's lots of online resources for omics, right? So if you go on like, so we have, what's it called? So the NHS in the UK has NHS Genomics, and they have run lots and lots of open access free courses on FutureLearn, which are to do with COVID-19 and genetics. And those skills are very relevant to NASA Gene Lab. So can you actually use the right programming techniques? Can you use the right interfaces in order to look at, to run omic sequences, etc.? I'm not a geneticist, so I'm sorry if I've like offended anyone with my terminology, but essentially these are big data, it's big data acquisition. And what can you do in order, genes are huge, there's a huge amount of data and it's all open access on NASA Gene Lab. Have you got a question and can you answer it using the data in front of you? And do you have the toolkit to do that? So programming, I would say coding, learning how to code. These are important basic skills that are required if you want to go into omics and genomics. So genetics is very different from genomics. I'd like to say as well. So genetics is more to do with the medicine side, counseling somebody about whether they've got genetic disease. Omics is about data analysis. So they're also two different areas, and they're two different areas that also have translational roles in medicine and in space medicine.
All right, thank you so much.
That's okay.
Yeah, for the great advice and answer. I would like to also ask Ayantika to unmute herself and ask her question. Hi, Ayantika.
Hello. Hello.
Yeah, we can hear you.
So I'm done my microbiology master's degree in University of Calcutta. So what can be the next step for me if I want to done life science as my career?
So I heard a few bits. I think the microphone is a little bit, but essentially I think you've done a degree in microbiology. But what was the question? Did you get it, Subrat?
Yeah, so she has it in the chat as well. So she has completed her master's degree in microbiology. What should be her next step? Because she wants to join the space life science domain as a profession. So after doing a master's degree in microbiology, what should be her ideal next step?
I would say that you can do what I did, which is essentially, I didn't know whether anyone was doing any CPR resuscitation research. So I literally looked at OVID, PubMed, Medline for who were the labs around the world that were looking at space resuscitation. For you, it would be who is looking at space microbiology or space immunology. Look at the first author and the last author. And it says contact author on those publications. Contact those authors and ask, have you got any role? Am I, this is my skill set, this is my CV, brief introduction, make sure your CV is 2 pages, 2 or 3 pages, not any longer than that. List your publications, etc., your skill set, and say what you would like. So if it's microbiology is a huge area. So do you want to look at, I don't know, immune modulation in certain diseases like the common cold, for example? That's a completely different question to, right, I want to look at bacterial growth in space. That's very much basic life sciences. That's one thing. So contact people in your area, and you might not know your area because you may not have done that Google search yet. And that's okay. It's important to just work out which labs are doing microbiology. The second thing is go to join Cellgra. So the student Earth and low gravity association. Essentially, CELGRA is the organization for life scientists who are looking at lab-based research, so especially microbiologists. So if you want to speak to other microbiologists in space, CELGRA and their conferences and workshops are the other place to go. Not IAC, not ASMA. So depending on what you're interested in, the different conferences will apply. So for genomics, NASA HRP and NASA Gene Lab runs its own conferences, and a lot of them are virtual. You can apply for free for NASA HRP. You don't have to go to Texas. So it's really important to just look at that. So I think those two things: contact the labs directly in the area of microbiology you're interested in, and if it doesn't exist, write a paper or literature review in that area, and submit it as an abstract to IAC. See where you get to, whether it gets accepted. What's the worst that could happen? It doesn't get accepted. I would also say that in my early papers and my early presentations, my supervisors were terrestrial. Some of my papers I submitted alone. So essentially to student conferences, I had one called, how to do CPR in space, how to lifeboats in space or something. And I did that by myself. And it's just a review. Anyone can do a literature review. If you've got a master's degree, that is a skill you have. And that's something you can start with. And that will be a conversation starter when you go to a conference. And never go to a conference without having something accepted is another thing that I would say, because you're going all that way, paying all that money. Always make sure that you're not just networking, but you're also presenting if you can. And that's something that I would say. You can even do it locally. You can even have a local presentation. It doesn't have to be, in Paris or something. It can be in your university, and you might find other people who are interested in space, and you can collaborate. This isn't a solo exercise. Space, life sciences is so niche. You need other people, you need a team to do it, because you're trying to achieve your competencies normally, like you're doing a PhD next, etc. You don't have time to do big projects by yourself. You have to find your crew. You have to find your team. And I would say that's really important.
All right, thank you so much, Rochelle. Before we move on to the other questions, I would like to ask you, how much time do you have left for?
I don't know what time it is, actually. I'm okay at the moment. It's 5:30, so I know that we're running over. It's how much time do you guys have? So I'm happy to stay.
Yeah, sure. We can have maybe 5 or 10 minutes more. We can extend it by then. So Upasana has raised her question, so I would allow her to unmute herself and
Hello, ma'am.
ask the question as well.
Hi, am I audible?
Yes.
Yes, thank you. Okay, so I wanted to ask this, as you have already said about IAC. Yes, I have a presentation. I already presented something on IAC, and this has been already done from my side. A research paper a review paper has already been published. Now, what the problem I am facing is, right now I am in Poland, in Europe, and being from an Indian, an international student, there are so many requirements, so many institutes that just want European citizenship. And if I'm going for NASA internship, they want just US citizenship. And I really wanted to do something in this summer internship, in the upcoming summer holidays, something related to space agriculture, something like a Melissa project. So do you have any of that in mind in which I can approach?
I would say that if you're not getting anywhere with applying for these, so I'm not eligible to apply for any of the NASA courses, even though I'm based in the UK. So I think it's very strict in terms of who they accept, and they only accept US citizens for a lot of the NASA stuff. Because you're at a Polish institution, it might be easier for you to actually apply for the ESA stuff. And even though the website may say that they don't accept people from certain backgrounds, they they're a bit more open when you email them. So it might be that you just have to drop them an email and ask. I don't know whether you've already done that.
I have already done that, and most of them got a negative response saying, we do not have a funding. Oops, we are sorry. Or maybe you are an Indian citizen, we don't have a citizenship. Even though I said I have a resident permit, for temporary resident permit, but still.
Yeah.
So I don't
sorry to hear
understand,
that.
like, I don't want to run into politics, but it's just like, aren't we have a, fair chance to learn something? Like, I don't understand this part.
I think it's because of how ESA is funded. So it's all the money. It's where the money is, unfortunately. So the money is by members of the EU and the UK, which has Brexited. But essentially, all the wrong reasons. Anyway, that aside, but essentially they have to prioritize, unfortunately, their member states, and then they will prioritize people from other nations. The UN. So if you look at the UN website and the UN USA website, they have internships over the summer. So UN USA has lots of internships, and it doesn't have to, it depends what you want to do. But if you want to break into the space sector, you have to be willing sometimes to go outside of your comfort zone and to go outside of your, so there are internships, I think they're advertising at the moment, but it might, that will be applicable to you because obviously you're from India, yeah. So that's the state. So have a look at the UN website, have a look at the WHO website. So these are the two avenues, alternatives that are applicable to space.
Could you please repeat, ma'am, what the WHO something you said? Could you please repeat?
So the World Health Organization. Okay. And the United Nations, but also the UN USA. So UN USA has lots of different little arms. So they've got the disaster management arm. They've got WHO. You've got like the infectious diseases group. You need to. It will be a lot of emailing, and you may not get responses. And unfortunately, I've been there. I've done that. I've emailed 50 different people for my medical elective. I got 2 responses back. It is. You need to keep knocking on the doors. And unfortunately, lots of people are knocking on doors. So you need to keep going. And while you're knocking on doors, you also need to develop your USB. So you need to always have a plan B. And for the summer, I would say, if you're interested in space agriculture, do something to do with agriculture in a lab near you. And then, like I said, have a part of your project that's maybe relevant to the space side. Ask your supervisor whether you can do something a little bit left field, or do, like you've already presented at IAC, can you take that further? And can you approach people that you've reviewed, those labs, can you approach them and ask them whether they've got any mini projects that can be done as an internship? And that might be another way to approach the issue. I'm sorry that you're not eligible for the ESA and the NASA like courses. I'm not eligible for any of the NASA ones or any of the JAXA ones. So I think it's just go outside and always have a plan C as well, which is doing your own literature project on something else that's relevant to space agriculture. There's always more questions to ask. And I think that to think about it like that, you know, you can do that from anywhere, a literature review from anywhere. You can put a team together from anywhere. But definitive stuff is applying for internships with the UN and with the WHO.
Okay, thank you so much for your answer.
That's okay.
Thank you, Rochelle. For the next question, I would like to ask Gayatri. Gayatri, would you please unmute and ask your question? Okay, I will ask her question because she has it in the chat. So she says, I am a student in Scotland studying project management and would like to do an internship. How should I reach out to companies with space-related projects?
So I don't think you might not necessarily, again, you might not necessarily get a space-related project. You have to think about your skills map, and I'll go back to it. It's really important to actually think about where is your gap analysis in skills. Okay, so if you want an internship in project management, you can do a terrestrial role. in any project management company, because I don't know whether you guys know about Harriet. So Harriet Brattle, so she does a lot of project management within her role at the moment. Essentially, her initial role was nothing to do with space. So I think that it's really important to think about what are your transferable skills that you can gain in that next role that you're going to do. It doesn't have to be a space project or be called a space project. A lot of my projects weren't, but I acquired skills along the way that led me to space projects, because unfortunately, it's like a chicken and an egg scenario. Everyone desperately wants a space life sciences role. They're very few and far between, or you have to make one yourself. You have to come up with your own space project management role. I would also say, look at the We Work in Space website. It's a new website. It's by Jules, who Lancy, who was one of our webinar leads for SMLS. But essentially, that shows you roles in project management and other things that are not mainstream space engineering, because a lot of the roles are space engineering based. It's, if you want to do project managing, then work out whether you could do a random project on Earth, and what are the skills that will then help you take that step forward to your space career. So I think it doesn't have to be space related.
All right, thank you so much, Rochelle. Here's another question from Janani. She says that she's currently doing her master's in biochemistry from Bharatiya University in Tamil Nadu, India, and the Institute of Aerospace Medicine in Indian Air Force, Bangalore, have the Aerospace Medicine course, but they need the eligibility of MD or MS. So what can she do to land on the aerospace medicine field?
So I would say, as a medical student or at an undergrad or intern level, it's important to start with literature reviews, start with reviews, basic things. You can do very basic sciences research projects within your lab. Again, make sure a chapter is to do with space. And I think it's hard to know what that project's going to be. I can only give an example of doing something like, so I looked at gender differences in rescuers that did resuscitation or CPR. And then I said, oh, how does that apply to male and female astronauts? So you need to really think outside the box of projects that you can do where you are in your geographical location now to move you forward. For the postgraduate ESA course and for the Indian Aerospace Institute course in Aerospace Medicine, you do have to have an MD. And the reason being that you need to have experience in medicine in order to become an aerospace medical doctor. And you need to acquire these transferable skills in all these domains if you are doing medicine, in research, education, mentorship. So make sure that you map out your plan. So say you're going to do this course in 2024 or 2025. What are you going to do in those interim years? What roles are you going to take in order to get the skills to get that job? And only you can map it out. And it depends on your local knowledge, on your local roles that you can get, and that could be teaching medical students on the bedside. It could be working out how to do a bit of research in the lab, joining an SGAC committee role to manage an SGAC team. It doesn't have to be necessarily only about space medicine. So that's really important to know. To get there, you need to know your stepping stones. And for aerospace medicine, these are your stepping stones.
Yeah, that's really very valuable suggestion, Rochelle. Here's another question from Manus. He asks, is biomaterials related knowledge relative when it comes to spacesuit design and development?
Yeah, it is, definitely. So I do know a few people who are involved in that and who work with engineers. So spacesuit design is very complex. You have a very large multidisciplinary team associated with that. And in terms of space materials, I think there's a PhD at the moment that they're advertising at King's. I don't know whether they've closed it. If anyone's interested, and it's looking at spacesuit designs and aviation, and it's based in Cornwall. So I don't know whether that's relevant to anyone. It's an open call at the moment. but that's looking at biomaterials. And I know that King's do a lot of work with Farnborough in the UK with spacesuit design and how biomaterials work. It's difficult because that's a very niche field in itself. It might be better from a biomaterialistic point of view to actually work with the spacesuit engineering team. But also biomaterials are very useful when it comes to storage of, say, medical drugs. How does that work? How does the pharmacodynamics and pharmacokinetics change if you have different materials that encase a capsule that packages up a little drug? So pharma might be another area to explore when it comes to your career as well.
Thank you, Rochelle. And here's the last question for today's workshop. I intentionally saved it for the last one. So this is from Ivan Zolo, a global surgery fellow in South Africa. And he asks, how can we contribute to ensure that space-based surgical care solutions are accessible and affordable to those who need them most, particularly in low-income countries? And also he asks, how can we get in touch with you, maybe through your email or any other platform?
So how can we make them accessible? So I know that during the Austrian Space Forum last mission, we had 3D printing of space surgical tools. I don't know whether anyone's used a 3D printer, but it takes forever to print anything at the moment. And these printers don't like dust. So working in the desert with a 3D printer is not fun. So essentially, in remote environments, it's very difficult to transport a lot of these tools that we've developed for space flight. But perhaps it could help with manufacturing quickly, and that might be able to be disseminated to local areas. In terms of space surgery, that's a very, very, very new area of space medicine. I do know people in the area, and I know that Eleanor Frost did some work on for her master's in aerospace medicine at King's, looking at how can we actually have like a closed field in order to do any minor surgical operations, because in space you don't want blood everywhere, and you need to work out channels for how do you suction away all that fluid in order to have a clear field to do a surgical procedure. You may have heard of the Da Vinci robot, way too big to transfer up to space. We have one at our hospital to do urological bladder surgery operations. I've anesthetized for them. They are I don't know whether anyone's seen it in operation, and it takes a long time to actually do a procedure that would take a human surgeon. So a human surgeon would take maybe 30 to 40 minutes to do a procedure. The robot will take 3 to 4 hours. So I think that we are not there yet with space surgery in terms of making those tools portable to go to anywhere, let alone a remote setting. I think that the one way that they could help is if you have a space surgical tool like the Da Vinci robot in a hospital in an emerging nation. Could you actually have somebody who's the expert in a very small part of cancer biology or oncology, like a space surgeon, a normal surgeon, sorry, to do that operation remotely, right? So maybe they don't, in a certain country, they do not, an emerging nation, they do not have that specialist. Could that cardiothoracic surgeon go online, do the operation in real time? So I think that's where there's a lot of research being done on Earth. And that's applicable. Like, imagine if you had the data and you had that bandwidth to do that operation on Mars, because then you wouldn't need to take a cardiothoracic surgeon, a neurosurgeon, etc. Not that post-operatively they probably won't survive because you need a lot of intensive care, but that's another talk. But essentially, that's my answer, is that we don't have the tools yet to transport them to the remote environment.
All right, Rochelle, thank you so much for your very insightful answers, and I'm sure everyone enjoyed your talk as much as I did. Once again, thank you for your time and thank you for coming today.
Brilliant. I'll just give you my email address as well. I'll write it on here if you can still see my shared screen, so that so it's rochelle.velho@spacegeneration.org. So that's the best email for me. I don't know whether everyone can see that. I can copy it into this chat, or I'm sure that Subudget can send it to people afterwards as well. So that's the best email for me. And then I'm on Twitter as well as Astromark Mars Rocky. And LinkedIn, please add me on LinkedIn. But thank you for all your really insightful questions and for inviting me today. I hope I've answered everyone's questions.
Yeah, I see Gayatri raising a hand still. So if you are still wanting to ask something, you can unmute.
Yeah, sorry, there was some issue with the PC, so I couldn't unmute them. So I'm studying in the UK. I'm in Scotland, and I'm studying project management. And I would like to, like I was talking about projects in regards to space and how I can approach, because we have an internship and we are supposed to write a thesis. And I would be really interested in doing a thesis around that. So I wanted some advice. Since you're, Rochelle, you're in UK, I'm at Scotland in Strathclyde University. So I have the permit to move around and do my internship. So if you can advise, it would be really helpful.
I know. So in terms of project management, I don't know whether I'm best placed to give you advice on that, because this is more aerospace medicine and life sciences but I can maybe point you in directions. So I would say that, like I said earlier, doing something at your stage, acquiring generic project management skills, even if they're not in a space related company, is really useful to then spin out into a space related role. So it's important to get your basic foundational skills in project management down. And that can be in any company. So that can be your plan B. If you want to do space for sure, then there's companies like Astroscale. There are other companies in Scotland that focus on space flight that might be useful for you. I can, if you add me on LinkedIn, I can send you some links and to people. But We Work in Space has some opportunities for like internships in project management as well. Space Careers UK has lots and lots of resources as well. So UKSED set it up. Well, people from UKSED set it up, and basically they've got a lot of knowledge about project management per se in space.
Okay, I've added you on LinkedIn, so I will write to you so you can share the links.
Yeah, we can talk about it more offline.
Thank you so much.
All right, thank you so much. And that brings us to the end of today's wonderful workshop. And thanks everyone for joining. Once again, thank you, Rochelle, for your time and for your valuable insights.
Thank you very much. That's brilliant. I hope, please reach out. I don't bite. I'm happy to answer your questions.
We will definitely reach out.
Hello, Subrajit. Can I ask you? Sorry to interrupt in between. Can I ask something?
Yeah, but please be really quick because we are going to wrap it up really soon.
Okay. Hi, Rochelle. This was a very good session.
Thank you.
I'm a student of astrophysics in NIT Rourkela here in India. I'm seeking some internship for this summer only. Where can I head?
I don't know much. I have to put my hands up and say I don't know much about astrophysics because it's not my area. But I would say that there are lots of different resources out there. I think the UK Space, UK Space Careers website has a lot on how you can get internship in engineering and physics. I'm not the best person to ask, I'm afraid, for that. I'll put my hands up and say.
Okay, thank you very much.
I'm sorry, I can't
answering, by the way.
It's okay.
All right. Thank you so much, everyone. And I would bid all of you farewell for now, and I'll see you all very, very soon. So if you're interested in the 2023 spring mentoring session, do keep an eye out on our website, and also keep looking at all the SGAC social media platforms for more updates. And as Rochelle said, you're always welcome to join all the project groups, especially the SMLS, if you are interested in learning more about the opportunities in which you can participate. So that's it for today's workshop. Thank you, everyone. And I wish you a great evening or a great day ahead.